Okay, the questions on page 238, starting with number 19. These are all kinetic energy questions. Number 19 says a 0.1 kilogram tennis ball is traveling 145 kilometers per hour. What is its kinetic energy? So it's giving you the V. It's 145 kilometers per hour, which of course you have to change to meters per second. And it's giving you the mass. It's 0.1 kilograms. And changing 145 to kilometers per hour is 40.27 with the 7 repeating meters per second. So kinetic energy, EK, is equal to 1/2 mv squared. So 1/2 0.1 kilograms times the 40.27 meters per second, and just that gets squared, just the 40.27. So square it, multiply it by 0.5, multiply it by 0.1, and you should get 81.115, rounding a little, 81.115 joules. Okay. Number 20, a bowling ball traveling 0.95 meters per second has 4.5 joules of kinetic energy. What is its mass? So this time it's giving you the kinetic energy. It says it has 4.5 joules. And it's giving you its velocity, 0.95 meters per second, and it's asking you to find mass. So again, EK is equal to 1/2 mv squared. You need to rearrange, so multiply both sides by 2 and divide by v squared. So m will equal 2 EK over v squared. So 2 times 4.5, that should be about 9, divided by 0.95 meters per second, and that gets squared. And you should end up with an m of 9.9723 kilograms. All right, and number 21 says a 60 kilogram skier reaches the bottom of a ski hill with a velocity. So a 60 kilogram skier reaches the bottom of a ski hill with a velocity of 7.25 meters per second. Find the kinetic energy. They should have led with this one. You didn't have to convert. You didn't have to rearrange. Just fill your numbers in. So 1/2 of 60 is about 30. And then times 7.25 meters per second, which first you need to square. And when you do, you should get 813.406 joules. All right, number 21. Now you're going to flip the page over to 245, and these are still kinetic energy questions on 245. Number 22 says a 6.3 kilogram rock is pushed horizontally across a 20-meter frozen pond with a force of 30 newtons. So the F is 30 newtons. Now, it tells us the length of the pond, and I think that's just to let you know that you don't push it off the pond. Because then it says, find the velocity of the rock once it has traveled 13.9 meters. So the delta D is 13.9 meters. All right, and you want the V final. The V initial, the rock's not moving before you pushed it. How do I know? Because rocks don't move on their own. So we need to use that the work done is equal to the change in kinetic energy. And we know work done is F delta D cos theta. And we know the change in kinetic energy is 1/2 V final, 1/2 mv final squared minus 1/2 mv initial squared. The V initial is 0, so this term disappears. The angle is 0, so cos theta becomes 1. And we're looking for VF. So multiply both sides by 2 and divide by m. And you'll get Vf squared equals 2F delta D over m. Now if you had wanted, you could have done this first and gotten your W and then set it equal to 1/2 mVf squared minus 1/2 mVi squared. It would be the same thing. So 2 times 30 newtons times 13.9 meters, and the mass was 6.3 kilograms. And remember, this is going to give you V squared. So you're going to get 132.38 meters squared per second squared, and then you're going to take the square root. And you're going to get a VF of 11.506 meters per second. Okay, that was probably the toughest one maybe of all your homework questions or practice questions. 23, the mass of an electron is 9.1 times 10 to the negative 31 kilograms. It possesses, what speed is it traveling if it has a kinetic energy? So EK of 7.6 times 10 to the negative 18 joules. So you need to rearrange for velocity. So EK is equal to 1/2 mv squared. Multiply both sides by 2, divide by m. So v squared is equal to 2ek over m. So 2 times 7.6 to the negative 18 joules divided by 9.1 times 10 to the negative 31 kilograms. And remember, again, this is going to be v squared. You get something like 1.6685 to the 13th meters squared per second squared. Take the square root, and you get 4.0847 times 10 to the 6th meters per second, which is pretty fast, but that's valid for an electron. Number 24 says, a small cart with a mass of 500 grams is accelerated uniformly from rest to a velocity of 1.2 meters per second. So our mass here is 0.5 of a kilogram, VI is 0, and VF, it said, was 1.2 meters per second. And it says it's doing this over a distance of 0.1 meters. So delta D is 0.1 meter. And it wants to know the force. So again, its work done is equal to change in kinetic energy. So whenever it's talking about a distance and a force and a change in speed, it's going to be work done is equal to kinetic energy, or F delta D is equal to 1/2 mvf squared minus 1/2 mvi squared. It says from rest, so the vi goes to 0. We're looking for F. So F equals 1/2 mvf squared over delta D. So 1/2 of 0.5 kilograms times 1.2 meters per second squared over 0.1 of a meter, 1.44, 0.72, 0.37, so I think it's 3.7, maybe 3.6, 72, yeah, it's 3.6. So 3.6 newtons should be our F. All right, number 25, which is over on the next page, says, a child's toy race car travels across the floor with a constant speed of 2.1 meters per second. It possesses 14 joules of kinetic energy. What is the mass? So it tells us the speed is 2.1 meters per second, and it tells us the kinetic energy was 14 joules. So EK is equal to 1/2 mv squared. So m is equal to 2ek over v squared. So 2 times 14, which should be 28, divided by 2.1 meters per second squared, 4.41. You should get 6.349 kilograms. And I'm going to run